Hello and welcome back. This is going to be the second video on section 12-2. And in between making the last video, the previous video, and this one, I got to thinking, I think we can do this very quickly, the second part. It doesn't have to last nearly as long as the first video. As you can see, I'm still wearing this stupid Halloween wig. I haven't gotten a chance to get a haircut yet. I look much better in a silly wig than I do in like a cap. I don't wear caps. That's just kind of a policy of mine. Anyway, okay, so here's the next test that we need to talk about. Chi-square test for independence. And the reason I led into this video by saying that I think we can do it really quickly is because, I mean, these two tests are essentially run exactly the same way. Okay, you write hypothesis statements. You put your data in a two-way table. You compute the expected cell counts, or you have your calculator do them for you. You verify the conditions. You calculate chi-squared, get a p-value, draw a conclusion. So what I'd like to focus on here are the differences, because really probably the biggest challenge in this section is distinguishing between whether you need to run a chi-square test for homogeneity and a chi-square test for independence. Okay, because while they're run the same way, the hypothesis statements are different. The conclusion is a little bit different, and the conditions that you need to check are a little bit different. So I'm just going to lay it out there right now. Here's how you tell the difference. You look at how the data was collected. If you have multiple samples, multiple separately selected samples, in the previous video, we had a randomly selected sample of young people and then a separate randomly selected sample of old people. Anytime you select two or more separate samples from the respective populations of interest, that is going to be the time that you will run a chi-square test for homogeneity. With a chi-square test for independence, you select one sample. And then from that one sample, you divide the people into their categories and place them in the correct cells. Okay, so the way, here's talking about the same situation as we were last time, I could have selected one giant sample of 800 people without regard to their age, whether they were above 40 and below 40. And then once I had that sample of 800 people, what I would have done is I would have made the table look exactly like I did in the last one, young, old, okay? Category for the three shows, okay, for each of the three shows. And then for each one of those, for each person in that sample of 800, they're going to fit into one of these 6 cells. They're either going to be young and like The Office, old and like The Office, young and like Parks and Rec. And you generate your observed cell counts that way, okay, from a single sample. If you select, if your data comes from a single sample, you're going to run the chi-square test for independence. Okay, it's as simple as that. So let's talk about what's different then with the chi-square test for independence. Well, the difference is in how the sample is selected, but let's talk about how the hypothesis statements are different. Well, the null hypothesis for a chi-square test for independence, okay, I'm going to pretend here like I'm doing that same example that I did in the last video, except this time I'm going to work from a single sample of 800 individuals, okay, from the population, from the whole population. It looks like this. Age and TV preference are independent. Okay, that is the most common way to write a null hypothesis for a chi-squared test for independence. There is another way. means exactly the same thing, but what you can say is there is no association between age and television preference. Okay, I prefer this way since it's a chi-square test for independence, and this has the word independent in it. And then the alternative hypothesis would look like this. Age and TV preference are not independent. Okay, so very simple hypothesis statements there. And of course, the alternative way to write that one would be that there is an association between age and TV preferences. Okay, so the null hypothesis is that regardless of how old you are, you're going to tend to, people of this age, in this age category, are going to tend to like the three shows with the same proportions as people in the other age category. There's no association between age and television viewing preference. And then the alternative hypothesis is that there is, that maybe the preferences for the older generation are different from those of the younger generation. Okay, so the null and alternative hypotheses are different. That's how they're different for a test for independence than they are for a test for homogeneity. Now you construct the table the same way, get the expected cell counts the same way. It's the same test on your calculator. Okay. The conditions are a little bit different. The one for every expected cell count has to be at least 5. That's the same. So one of the conditions for the chi-square test for independence is the same as it is for the chi-square test for homogeneity. All expected cell counts have to be at least 5. Okay. The other one is the one that's different. Okay. Then the assumption is that it is a random sample from population of interest. Okay. Notice a single random sample from the population of interest. Okay. So those are the two conditions for a chi-square test for independence. From there, you calculate the value of chi-squared exactly the same way as you did in the test for homogeneity. You either do it cell by cell, okay, and then add those up, or you do it on a calculator the same way we did in the previous video. Now, what else is different? Well, the conclusion is different. Since the null hypothesis was different, the conclusion is also going to be different. The null hypothesis was that age and TV preferences were independent. Okay? So if p is less than alpha, we would reject the null hypothesis. Okay, and we'd say that there is sufficient evidence to conclude that TV preferences and age are not independent. Okay, there is sufficient evidence to conclude that TV preferences and age are not independent. Now, if you fail to reject the null hypothesis, you would say there is not sufficient evidence to conclude that TV preferences and age are not independent. Okay, now this was a pretty fast video. If you need more of an explanation, you can reach out, but I think you should be able to do the chapter 12 problems now. For each problem, the main thing is determine, am I running a chi-square test for homogeneity or am I running a chi-square test for independence? Remember, you have to look at how the data was selected. Okay, from there you run them the same way, but if you have to choose hypothesis statements, remember you got to choose the correct set of hypothesis statements, and that choice will be made on the basis of which of the two tests, independence or homogeneity, is appropriate for the given situation for that problem. Okay, I think that'll be it. Thanks for watching, and we'll see you next time.